So here we're looking at quadratic formula again, but at the end we're going to make sure each answer is simplified. So the previous assignment, I didn't have you worry about simplifying it, but now I'm going to show you how. So I will expect your answers to be simplified. So to remind you, your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So the first thing we have to do is get the equation equal to 0. So I need to move this 12r and put it in order. So I have 7r squared plus 12r minus 8 equals 0. Now it's in ABC order, and now I can continue. So negative b is going to be negative 12 plus or minus the square root of b squared. B is 12, so 12 squared minus 4 times a, which is 7, times c, which is negative 8. And then I'm going to put that over 2 times a, so 2 times 7. And now I'm going to evaluate everything that I can. So 12 squared, I'm looking on the inside of the square root now. 12 squared is 144. Then I'm going to do negative 4 times 7 times negative 8. So negative 4 times 7 is negative 28. Times that by negative 8. Double negative, so positive is going to be plus 224. So I have 144 plus 224 inside the square root. Add those together. I'm going to get 368. Then I'm dropping down, plus or minus, drop down to negative 12. All over 2 times 7 on the bottom is 14. So now I want to test, can I actually square root the 368? So if you type the square root of 368, type that in your calculator, you're going to get 19.183326, some crazy decimal. So since it cannot be square rooted, then we want to try to simplify it. So to simplify the square root, so I'm just going to pull the square root of 368 off to the side here. To simplify this, I want to divide this into 2 square roots where one of them is a perfect square. And your perfect squares are 1 times 1 is 1, but that's not going to help us. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. Here's our perfect square list, and I could continue that. It's 6 times 6 is 36. 7 times 7 is 49. I could keep going and going, but that's probably enough to stop right there. So then we're going to take 368 and divide it by one of those perfect square numbers. You might want to start, divide by 4 is a good place to start. So if I divide it by 4, I get 92. So I'm going to split this into a square root of 4 times the square root of 92. Now I want to double check, make sure that 92 can't be divided by 4 again, and okay, it can. So what that means is I could have divided by a bigger number than 4. So I'm going to erase that 4 and the 92, and I'm going to go back and divide 368 by 16, because I can divide it by 4 twice, and so that means I can divide it by 16. So if I divide it by 16, I'm left with 23. So now I'm going to square root the 16, because I can, right? The square root of 16 is 4. So this is going to be 4 times the square root of 23. After dividing the 16, I should have mentioned you want to check this 23, see if it can be divided by anything else, but I can't divide it by 16, can't divide it by 9, can't divide it by 4. There's no point in checking the other ones because they're too big. So there is the simplified radical. So 4 times the square root of 23 is equal to the square root of 368. So I'm going to replace the square root of 368 with 4 square root 23. And I'm going to drop everything else down as it is. And then I'm almost done. Now the square root of 23 isn't going to change, but the other 3 numbers, the 4, the 12, and the 14, all of those can be divided by 2. So it's kind of like reducing a fraction now, except you have 3 numbers to look for instead of just 2. So you have to be able to divide all 3 of them by the same thing. Since they can all be divided by 2, I'm going to do it. So I'm going to have negative 6 plus or minus 2, keep the square root 23, all over 14 divided by 2 is 7. So there is the simplified answer. All right, so the only new thing is simplifying the square root. So if it can be simplified, simplify it. And to do that, you're checking these perfect squares. Check to see if the square root can be divided by those perfect squares. So let's go ahead and try number 2 here. So first thing I want to do is move this 3 over. So I have 4x squared plus 10x minus 3 equals 0. Then plug them in. So I have negative b. So negative 10 plus or minus square root b squared, 10 squared minus 4 times a times c, all over 2 times a. And now I'm just going to evaluate the stuff inside the square root. So 10 squared is 100, 4 times 4 is 16, and then multiply that by 3, I'm going to get 48. So there's a double negative. Right? So there's a negative on the 4, negative on the 3, so it's going to become a positive. Positive 48. So 100 plus 48 gives me the square root of 148. Plus or minus, I'm just bringing everything else down. 10, negative 10 in the front, 2 times 4 on the bottom, so 8. Now I'm going to check that 148 and see if it can be square rooted. It can't, not evenly anyway. So now I'm going to check those perfect square numbers to see if I can divide into the 148. So check 148 divided by, you can check any of them, you can do, I don't know, 36. Okay, it doesn't work. 148 divided by, no, it's not going to work with 25. Let's try 49. Nope, doesn't work. So 148 divided by 16. Doesn't work, but it's getting closer. 148, I know it doesn't divide in by 9, but if you don't know, then try it. So I divided it by 4, and I got, so this is going to become 4, the square root of 4 times the square root of 37. That comes from 148 divided by 4 is where the 37 comes from. So then that square root of 4 is just a regular 2. So then I'm going to write this as 2 times the square root of 37. So that negative 10 is, so now I'm looking back over here. So that negative 10 is going to drop down, plus or minus 2 square root 37 all over 8. And then once I got to here, I'm looking at those 3 numbers and simplifying those 3. So they can all be divided by 2. So I'm going to have negative 5, negative 10 divided by 2, plus or minus 2 divided by 2 is just 1. So you can put the 1, you don't have to though, since it's in front of a square root, it's unnecessary. So I have negative 5 plus or minus the square root of 37 all over 8 divided by 2 is 4. Okay, so simplifying the square roots uses these perfect squares, and remember that list continues. So I only went to 7 times 7, but you can do 64, 8 times 8, 81, and then 100, and continue on from there. All right, so if you have any questions about simplifying the square roots, let me know.